the marker so I can run my office out.
I never have a marker. Hold on, I don't think I do. Sorry. Someday I'm gonna actually get a marker. That would be amazing. Thank you. All right. First off, very first thing, does anyone have any questions from homework stuff? Questions? So homework's going okay? Yes? I like the looks I get when I say that.
Can we actually go over the first thing that we're being asked of for 3.4, like question 3? Just to clarify on it. I just glanced at it like 5 minutes ago.
Which one, sorry?
3.4.
3.4?
Yeah. Question 3.
Can you also look at 20 and 25 on 3.4?
I guess so. Oh, sorry, hold on. Oh, yeah. Yeah, this is a good question. So, what does it mean when you compose two functions? Does that mean you're writing it down on sheet music and you're playing it on a piano? I don't know what the hell composition of functions is. If you don't know, look at number 2. There you go. So what's a composition of two functions? What's a better way to say it? What does that mean besides how we sometimes feel we're in it? How do you say that? Anybody? Does anyone know how to rewrite that? What does a little O mean in the middle? Yes, F of G. So the right way to rewrite that is F of G. So all a composition of functions is you're taking one function and shoving it into another one. Putting it in if you want to. You guys know? So number 3 says, what if you shove G into F versus shove F into G? Does it have to be the same? Can it ever be the same? So let me show you an example. If I have a function x squared plus 1, and another function is x minus 2. Can you guys take a moment and tell me what f of g of x is? Don't say anything out loud. Try to figure out, do it, what f of g of x is. Go for it. Go for it. Now's the time to try it. Get it right, get it wrong, it almost don't matter at the moment. So can somebody tell me, what am I putting into what? I'm putting the function g into the function f. Yes. So a really good first step is to replace g with what it is. And now I want to take this and I want to shove it into f. Yes? So I just rewrite f, but in place of x, I'm going to put x minus 2. How we doing? If I multiply this out, I will get x squared minus 4x plus 4 plus 1 is plus 5. Okay, I did that quickly, but you guys get it. What about if I turn it around? Will it be the same? Will it be related? So this time I'm taking f and I'm shoving it into g. It's going to rewrite g, but I'm going to replace x with what? X squared plus 1. I'm going to take this, and I'm going to shove it into g. This will be x squared plus 1 minus 2. And what's that? Yeah. So how are these? Are these the same? Are these the same?
No.
Hell no. Are they opposites? No. Are they related? They both have a square. You see what I mean? So in general, I hope this kind of makes sense. If I shove one function into another, it does not have to be. In fact, normally it isn't the same. But does everybody understand now what the problem is asking? So I will say, in general, if you just pick two functions and you change the order of which one you plug into which, I would put all my money on it not being the same. But here's the key question. Is there ever a time when the output will be the same? And there's one answer that's kind of like silly. Why are the answers not the same? Because when I shove G into F and F into G, are G and F doing different things to their inputs? So G and F do different things. Hell yeah. So think about what I just said. What's the silliest way you can make it so that F of G is the same as G of F? What if F and G were the same? That's the silly way. Of course that would be the same then. It doesn't matter. If they're both the same, you're going to get the same answer. They're going to both do the same thing to each other. So a slightly more interesting question would be, are there an F and a G that aren't the same, but the output would be the same? Either way you did it. So I'll just leave that as a little challenge for you guys, because I'm pretty sure it's part of the question, right? What was it again? Can the result ever be the same? If yes, give an example. So you could give the example, let F and G be the same. And you would be answering the question, yes? But let's see if anybody, it's up to you if you want to take time to see if there's ever a time that F and G are different, but you get the same result if you plug G into F and F into G. Does everybody understand what I'm asking? You don't have to. You don't have to. Because you would be done with the problem. This is just one step further. Is that okay? Is that okay? Did you ask a question?
Yes.
Okay. Does that make sense?
Yeah.
Okay. I understand when you first read it, you're like, I don't know what these people want from me. Yeah. Okay. Anything else from homework stuff? All right. Okay. So here's what I want to do. Let's kind of review what we've done so far. We did a lot yesterday, believe it or not. Can somebody tell me if I have this, oh Jesus, if I have this equation, what do you got, Jeff? What happens if I do this? How does G relate to F? What's the differences visually, graphically?
Its position
Yeah.
to the right and going in a curve.
Sure, different curve. Can somebody else be more specific? How's it gonna move? So we're gonna have a square root function, yes? And what does G do to it? How does it change it? Is it gonna move left or right? Or up or down? I don't know. Where's this -3? Is it inside with the x or is it outside?
Inside.
Inside. Do you guys remember that was a huge part of this? If it's inside, it's going to be left or right. If it's outside, it's going to be up or down. Yes? So is that going to make it move left or right or up or down?
Right.
Yeah, left or right. In this case, specifically right. So when it's inside, it does the opposite of what it looks like. Okay. And I don't know if that sounds like we just decided to be evil. Let's make it to the up. No, it's just I'm taking 3 away, so all my inputs have to be 3 bigger. That's why it goes to the right. They have to be 3 bigger. So the inside is going to make it move right 3. What's that 2 going to do? Is it inside or outside?
Outside.
So is it going to go up or down? Or I'm sorry, up, down, or left, right? Say again. Up, down. And in this case specifically, it's gonna do what? It's gonna stretch up by a factor of 2, right? It's gonna double all of my outputs. So this is going to take the square root symbol, square root graph, and it's gonna move it right 3, and then it's gonna take this and it's gonna stretch it a factor of 2. Is that, you guys with me? So we did that like crazy yesterday, yes? You guys kind of, we talked about reflections, we talked about stretch and compress, we talked about left and right, up and down. Holy shit. Did we talk about, let me put this down here, vertical stretch, factor of 2. Did we talk in general about what the absolute value function looks like? Did we? Yes. What does it look like? Like a V. Oh, that's right. That's when you. Okay. We are very much overlapping with another class I'm teaching right now. That's why I'm like, did I say this to you guys or with them? So that's what the absolute value looks like. Yes. If you graph the function, and it makes sense. It's x. It's x. It's x until it tries to go negative, and it's like I can't go negative, so it just has to turn. So the absolute value of -1 is 1, so it turns, makes a hard turn. Okay. So that's just another function I can shift it up, I can shift it left, I can shift it right, I can stretch it, I can smoosh it, I can do all the same shit. Every function we can do everything to, and it works the same way. So even if I didn't know what the function was, what the function? If I had this, what do you want to say, Jeff? What would that do to the h function? I didn't even tell you what it was.
The right 5.
It would move the right 5. And? Up 2. You guys see that? Is everybody cool with that? It's okay if the answer is no. It's not okay if the answer is no and you don't say that. I'll give you more examples. It's okay. So if this doesn't make sense, let me know. Maybe? Alright. Okay. Yes, sir.
Or is there an example where the roles would be reversed?
How do you mean?
Like the alpha number would be would go like left and right.
Oh, not with what we're doing.
No. Oh.
Yeah. We're always assuming the function is a function of x with an output of y. Now, to be honest, we could turn that whole thing on its head. Kind of, I could have x as a function of y. Like I could have a parabola that opens sideways. And then you would do sort of like what you're saying. But, all right, I don't want to freak you guys out. It's a good question, but I don't want to freak you guys out. H of x, isn't that y? You with me? In fact, that's what we're going to assume this whole time. We're going to assume our functions are functions of x's and their outputs are y's. And that's why if it's outside, it's up and down. If I had a function of y, then that would reverse. You kind of with me? Okay, but let go of that. We're not going to do that. We'll do it a little bit. We'll look at some sideways parabolas, but we're not going to like shift them a ton. Yeah. Okay, maybe. Okay. So what this led into was a quick way to find the vertex. Where's the vertex for y equals x squared? Where's the vertex? 0, 0. Weehaw. So does anyone remember, without graphing, without doing much work at all, how to tell where the vertex is for this? So what are the shifts? How would it move? Right 2. So the vertex started at 0, 0, correct?
Yeah.
So it moves right 2. Down 11. So where did it end up? What point? 2. Down 11. So negative 11. You guys with me? 2, negative 11. Can you see it? All right, I really need you to see that. It comes straight from transformations. It just goes right 2 down 11. So if it started at 0, 0, it's now at 2, negative 11. So let's see. So if I took this point and I moved it right 2 and then down 11, yes? And then everything else just kind of comes with it. Obviously now the vertex is at 2, negative 11. I just followed where it took it. That's almost too good to believe. So if I give you something in this form, oh my God, Jeff, where did all the numbers go? If I give you something in that form, almost exactly like y equals mx plus b, why is that the best form for a line? Y equals 2x plus 3. Tell me anything you know about that line. Y equals 2x plus 3.
You have the slope and
Slope of
line.
Slope of what?
Slope of the line.
No. Tell me what the slope is. Y equals 2x plus 3. What's the slope? 2. Now somebody else that I haven't heard from yet. What's 3 tell you? Yes, the y piece of the y-intercept. Why does it tell me all that? Because it's in the form mx plus b. This is so cool. I don't know if I said this yesterday, but later we're going to talk about circles. And if I put circles in the right form, the radius and their center comes out, because those are the 2 most important things about the circle. Why does it make sense that the equation tells me things about the graph? Because that's where the shit the graph came from. The graph is just graphing points that work in the equation. So of course they're connected. So if I have a quadratic and it's in this form, I can see the vertex. Have I talked to you guys about how to tell if it opens up or down?
Yes.
What part of this determines if it opens up or down?
A.
Huh? A. So first off, before I get too far, somebody else that I have not heard from, what's the vertex of this? How much did it shift? H in what direction? Right. Okay, so right H. Okay, so where is it now? Started at 0, 0. Right H. Okay, what point is it at now? If it was at 0, 0, and it goes right H, what point is it at now? H0. Now it goes up K. What point is it at now? HK. Well, how does that relate to this guy? This vertex was 2, negative 11. So this vertex is HK. Just because that's how it moves. It starts at 0, 0, so how it moves is exactly where the vertex is. Do you see how important, just like putting a line into mx plus b form, this is the same importance. So let me show you what I mean. If I give you this, is this quadratic? You can do it, Jeff. Is that quadratic?
Yes.
Totally. Can you tell me what the vertex is just by looking at it? No. Is it in the right form? No. So can somebody tell me, can somebody try to tell me why this is not in that form? What's the most immediate thing that tells you that it's not in that form?
There's 2 separate axes.
Okay, that's so cool. I love it. Do you guys see what he means? The first one, the official vertex form. That's what we call this because we're very creative people, math people. Vertex form. Vertex form has one x term, right? There's one term with an x in it. This one has 2 terms with an x in it. Okay. So the form I gave you the f function in kind of sucks when it comes to finding the vertex. Wouldn't it be good to know how to put that into that form?
Yes.
And I always love to watch students struggle with, I'd be cool if you didn't tell me. In general, it would be good to know, because then I can see the vertex, yes. Does anyone know do we have a process that we talked about that takes something that looks like this and make it look like that? Do we have a process for that?
Doing something this way.
Something with a square.
That was
Complete the square. Okay. We got so much. So everybody with the idea here, the motivation is, if they give it to me like this, like that one's nice. Look, Jeff, that was when you were nice, Jeff. Then I can see the vertex. If I give it to you like this, well, okay, Jeff, you suck now. I can't see the vertex. But let me do this. I'm gonna move the 5 over, is that cool? Gonna make some room? What's weird about what we're about to do is how many sides do I have to work with? I really just have one side. Now there is a way to do this, but I'm not, because it's a good skill to have anyway. I'm gonna work everything on one side. Does anyone remember the 2 steps to completing the square? What are the 2 steps?
I needed negative 6.5.
Yeah, I take this guy and I cut him in half. Half of negative 6 is negative 3, and then I take that and do what?
Square.
Square. What do I do with this number? What do I do with this number?
Put it in between 6 and
What do I do with this number? Yeah, so I add 9, right? Now, if I just do that, if I only add 9, have I changed the problem? Does everybody remember this? You guys see that?
Yeah.
First step, cut middle in half, then square it. That's what I add, and this is going to be how it factors. But do I still have the same problem I was given? Or have I changed it? Yeah, because before it was plus 5, now it's plus 14. So if I add 9 at the same time, what do I do to make overall I did nothing?
When you add that
No, I don't have 2 sides. Subtract them. Now, listen, on one level, that's dumb as hell, right? You with me? On one level, and I'm understanding. You guys are like, in your head, somebody out there must be like, what the shit is this guy saying? This guy just said add 9, subtract that. That's like, move the box over there and then move back. I'm like, what? Well, what I'm doing, does everybody agree that this is the same as that? Okay. And we've done great stuff because we just did nothing. Go team. But what we actually did was we reorganized stuff. How do I factor this piece?
X minus B squared.
Yeah, no thought involved. It's just this guy, right? This is x minus 3 squared. And what's 5 minus 9? Is it in the right form now? Yeah. So that's the trade-off. I don't want the function to change. I can't make it change or else I'm going to lose all the points because I'm answering a question that I wasn't asked. So if I add 9, I better subtract 9. On one level, that feels dumb as shit. But what we really did was we reorganized it. Now, what's the vertex?
Why is it minus 4?
Huh?
Why is it minus 4?
5 minus 9?
Oh.
Yeah. So the vertex, 3, negative 4. Is that cool? Can somebody tell me the y-intercept?
Negative 0, negative 1.
Do it again.
0, negative 1.
No. Thanks for playing. Real quick. I'm going to do this the long-ass way, and then I'll show you the shortcut. If I make x 0, I get negative 3 squared is? Come on. If I make x 0, work this out. What's negative 3 squared? 9 minus 4? 5. So why use this dumb thing? Why don't I just use this thing? If I make x 0 here, what's the only thing left? Do you guys see that? So here's the thing I think students sometimes forget. What is true and what must be true is this function is the same as this function. They are the same. In fact, we force them to be the same, yes? This function is the same as that function. So what is this guy's y-intercept? That guy's y-intercept. And if I make x 0, freaking 5, yes? Because everything has an x goes to 0. Do you guys see that? So you could use this But then you have to actually do the work. And that sucks. So why not just, oh, that's fine. Okay, maybe. Okay. So let's do this. I don't know if I did this last time. Let's graph this thing. So we got a vertex of 3, -4. And a y-intercept of 0, 5. So let's make a little graph. Whee! And how does this open? Does it open up or down? Yeah, how do you know?
A is positive.
Yes, A is positive, so it opens up. So the vertex is 3, -4. Okay, 1, 2, 3. Yeah. 1, 2, 3, 4, 5. Nobody will be seated during the amazing labeling the x's. Okay. X, Y. Good. Okay. What happened to you? So then I've got 3, -4. That's my vertex. In fact, I'm going to put a little V next to it just to remind myself. And then we also have the point 0, 5. Where's the mirror? Because every parabola, could a parabola look like this? No. If I change one side, both have to change. It's got to be a mirror image. Where is the mirror for any parabola? Right down through the vertex. Right down through the vertex, yes? This is really cool. I can't remember if I showed you this, because I showed it to my other class, and now it's all a blur. This here is the mirror. The technical name for this is the axis of evil. No, the axis of symmetry. It's the axis around which things are symmetric. Boogie woogie. So if there's a point here, and this is a mirror, where is there another point? There's a point here. This is a mirror. Where is there another point? How far is this point from the mirror?
2, 3.
So where's the reflection point?
6.
Yes, 3 over this way. Then I can make my parabola. Whee! Whee! Stop for a minute. You guys see that? You guys see that? That last point kicked so much ass. I didn't have to plug it in, didn't have to calculate it. I could just mirror image the damn thing. And then I know exactly kind of like what my parabola looks like. Bam. Let me write the function down again. What the function? Write the original form of it down here. How do I check myself? What point is that?
6, 5.
6, 5? So what does that mean?
26.
If I plug 6 in, 36 minus 36 plus 5, I should get 5 out, and I didn't. So you can always check your work. You take your reflection point and make sure it works. Because it's got to. If the graph goes through it, it's got to work in the equation. That's why we graph things. Now, to go even further with this shit, can you guys take a minute and factor this thing? Can you factor the function? Factor it. Just factor it normal. Not complete the square, just factor it. All right, what do you guys get?
-5,
So what are the x-intercepts? Can anybody see how you can just see them now? Because how do you find the x-intercept? How do you find the y-intercept? You make x0. So how do you find the x-intercept? You make y0. Another way to say that is you make the output 0. What x's make the output 0?
5 and 1.
5 and 1. And look, if I make my points big, 5 and 1. Now, if you played along with me, it might not go through. It depends on. No, listen. Tell me again about parabola. It's got an axis of who? Symmetry, which means it's symmetric around that axis, yes? So if I have a point here, there must be a point mirror image, yes? So if I have 2 points that I know, where would the vertex, if these 2 points are right across from each other, where would the vertex have to be? Right in the middle. What are my 2 x-intercept values, the x values? 1 and 5, correct? What's right in the middle of 1 and 5? 3, isn't that where the vertex was?
Yes.
So there's a shortcut in here. I'm going to come back to it later, but I just wanted to say it now, just because I have this in the right form. So hold on to that. It's very interesting. If I know the x-intercepts, where the vertex is going to be? Right in the middle. Why is that not a good general way to do this? Because can you always factor the function I'm given? No. But somehow it's going to lead to a beautiful shortcut. But first we're going to go through the long ass way. Here we go. We already did one. We did this completing the square. And you guys know completing a square can get a little worse. So let's make it a little worse. What you got, Jeff? Sure. Blah, 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 blah. Okay, I want, there we go. Look at that. Just gaze upon that. That is so gross. Bless you. So listen, the instructions would say, put this into vertex form. What that means is you have to complete the square. I am going to show you a shortcut, but not yet. So in general, if I say put it into vertex form, that means do completing the square. Can anyone remember? Let me do the first step. First step is make a little room. Can anyone remember why completing a square will not work the way this is?
A is not equal.
Say again.
A is not equal.
Yeah. What do I need here? I need a 1 here, yes? I don't have 2 sides. I can't divide g by 4. So what do I do instead to make this go away? I can just... I can just take it out. What do you get when if you factor a negative 4 out? What do you get? Take a negative 4 out of these two. What do you get?
X squared is minus 4.
X squared. Keep going. Minus 4x. Good. So far, does everyone agree this is the same as this? I haven't done anything, bless you, I haven't done anything that makes this different. You with me? I'm going to say something a little trippy, but you guys will get this. Is this really a negative 4 here? What's really here? This isn't a negative 4 here. What's really here? 16. This isn't really a 1. It's a negative 4, yes? Okay, keep that in mind. How do I complete the square here? What's the 2 steps?
You have
You cut this guy in half. What do you get? Negative 2. And then I take that and square it. What do I do with this? I'll tell you what to do with that, Jeff. Hey, what do I do that for? Huh? Add it? Yes. I'm going to put it right here, yes? Now, I did not just add 4. I didn't. What did I do?
You added negative 16.
Yes, I subtracted 16 or added negative 16. You guys see that? That's the reason I made that big point a second ago. If I put something in here, that's not 4, that's minus 16. Damn it, Jeff, you always think backwards on this. I'll be all right. We're not going to graph this. Does everybody see that? Well, I didn't have to worry about that the first problem we did because there was a 1 out front. It didn't change shit. Now there's a negative 4 out front. So we just subtracted 16, so what should we do at the same time? add 16. So I get negative 4. How do I factor this?
X squared minus.
So can you tell me what the vertex is? 2, 29. 2, 29, because it goes right to up 29. Does it open up or down? Good, because this is negative. And what's the y-intercept? 0, 13. You guys with me? Is everybody semi with me? It's very tricky. So you do that every damn time. Now, obviously, dear God, only do it if you're told to do it. I am going to show you a shortcut. And then I'm going to shut up and let you guys work on the worksheet. So here comes the shortcut. Does anybody want a shortcut? Does anyone not want a shortcut? Does everybody want to do it just this way every time? Or do you want a shortcut? Sorry. That's a perfect look I just got, like, shut up, man, just do it. All right. Stop trying to be math boy. Just do it. All right. So here's what's really cool. Didn't we say earlier, for example, if I had this, can anyone tell me what the x-intercepts are?
3 and 7.
3 and 7. What must the x value of the vertex be?
5.
Is that cool with everyone? Like, I know this function goes through this point and this point. Is everybody cool with that? I know it goes through those 2 points, yes? And since parabolas are symmetric, if I know there's 2 points across from each other, the vertex has to be right in the middle. It has to be somewhere on that line in the middle. So the x value of the vertex is freaking 5. Is everybody with me? 5. So how do I find where the vertex actually is? All I know is it's somewhere on this line.
You put A right there.
I just plugged the damn 5 in, right? 5 minus 3 times 5 minus 7. What's 5 minus 3?
2.
That's crazy. What's 5 minus 7?
Negative 2.
That's crazy. What's 2 times negative 2?
Negative 4.
Yes, so it's going to be 1, 2, 3, 4. So it'll be right there. Bam, bam. Is everybody with me? You guys with me? Anybody? Now I'm going to do 2 things. Can you guys take a minute and multiply that y I gave you? Multiply that out. Yeah, FOIL it out. Just do it. Go for it. Multiply it out. Do it. Multiply that. Go for it. The function I gave you. Multiply this out. So put it into ax squared plus bx plus c. So I get, what do you guys get?
X squared minus 10.
Yeah, minus 10x plus 21. Now watch. If I start doing quadratic formula, everybody's favorite, right? How does quadratic formula work again? Yeah, I'll put it down. Negative b, tell me, plus or minus?
B squared minus 4ac over 2x.
All right, good. So what's b?
1.
Huh? What's b?
Oh, b, negative 10.
Yeah, ax squared plus bx plus c. So b is negative 10.
Yes.
How's everybody doing? Negative 10 is 10. I'm going to do this. 10 is being divided by 2, and this business is being divided by 2, yes? What's 10 divided by 2? And what was the x coordinate of the vertex? 5. I really don't care about this part. So let me show you what's happening. There's a beautiful shortcut here. If I gave you a function that you cannot factor, how would you find the x-intercepts? How do you find the x-intercepts if you can't factor it? What do you have to use? You have to use quadratic, because to find the x-intercepts, I need to set it equal to 0, right? And whose job is it to do that if I can't factor? Quadratic formula, that's why it exists. We created it to do one thing. Pass the butter. No. Give me the intercepts. So if I do that, let me write this in a different way. Basically the way I just had it written. Does everybody see that if I take this number, whatever the shit this number is, I'm going to add this much to it, and I'm going to subtract this much from it. So if I just put down here, negative b over 2a, and I add this much to it, and I subtract this much from it, those are my x-intercepts, correct? I can plug all this shit in and get the numbers, I almost don't care. So what did we just say earlier? If I know the two intercepts, if I know any 2 points across from each other, where must the vertex be? The x piece must be in the middle. What's always in the middle? Always. This. Even if they're complex, that is in the middle. And we already knew that the stupid vertex x is going to be in the middle of the intercepts, and that's what quadratic formula does. It finds intercepts. And what's always in the middle of that, dude? Negative b over 2a. So Jeff, what the shit does this mean? Did we do, what was the, yes. Look at this problem again. We did this problem, yes? Can somebody tell me what b is? 16, is it very cool? So it'll be negative 16, what's a? Okay, what's negative 16 divided by negative 8? And what was the x piece of the vertex? Do you understand? Does anyone understand? So this shortcuts all this shit. I can just get straight to the vertex if I use this shortcut. Now, real quick, have I got the vertex yet over here? I have the x piece of the vertex. How do I always finish it out? If I have the x, I just plug it in. And if I plug 2 in, negative 4 times 4 is negative 16, plus 32 plus 13 is 16 plus 13 is 29, which is what we got freaking earlier. Yes? Isn't that crazy? I don't know if anybody's with me. So you are going to have to complete the square. You just are. Because, check notes, I'm evil. But we now also have a shortcut. Just to get the vertex. Okay. Maybe. Okay. So let me give you this. Yeah, let me give you this. So on one side is some examples of putting parabolas in the vertex form with the completing the square business. And then the other side is some problems that I want you to work out. Alright, so I'm going to give you the option. You can work alone or you can work with people near you. If you could work on these problems on the back. If you want to, this is the one that says use the shortcut. You can do that right now if you want to because we just talked about it. This one you got to complete the square. These are quick. And the last problem is weird, so we'll see if anybody can do that last problem. Call me or Christine over if you need some help. If you want to work with other people. All right, guys, let's take a look here. The first two, I'm hoping, were pretty damn straightforward because they're already in the right form, right? So, what's the vertex here? 5, negative 11. Does it open up or down? How do you know it opens up? because this is positive here, right? So over here, what's the vertex? Careful. Yeah, negative 5.1? 13. And does it, how's it open? Up or down? Good, because, good Lord. Because that's negative, yes. Okay, I like it. How are we doing so far? So if it's in that form, it kicks ass. I'm like, oh, the work's been done. I just have to look at it. Yes? It really kicks ass because they didn't make you graph either one of those. So number 2, again, if I say put into vertex form, I mean complete the square. So now listen, if I'm you, I'm still going to do the shortcut just to make sure my answer comes out right, because the shortcut kicks ass. But for some reason, Jeff wants to torture you and still make you do the completing the square. Maybe because it's important and it's going to come back later. But so what are my first 2 steps to complete the square for this poor little dude? I don't do anything with this. Why do I not do anything with this? Yeah, make space. I like that. I heard that. Make some space. But why can't I just cut this guy in half? What's wrong? What do you need here? So what do you have to do? Take a negative 2 out. And then what you're left with? Negative 4 divided by negative 2 is positive 2x. And now I can focus on completing the square for the stuff on the inside, yes? Yes? Do it again? Okay, I love it. I love it. This is perfect. Sorry. The question is, hey man, we went over factoring. Are you feeling all right? Why didn't you take an x out? You all agree with me an x could come out of these 2, yes? Now, overall, are we actually factoring? No, we're doing something very specific. I'm trying to complete the square. And why are we doing that? It's always good to remind ourselves what the point is. The point is, I want to make this look like this. Right? I want to make this look like this. Is there an x outside? Good, but there's a number outside potentially, right? Okay, that's why I don't take an x out. If I did, it wouldn't be squared anymore. I couldn't complete the square. Okay, so that's a really good question. Same exact question this morning in my other class. Good question. I don't blame you. We're not really factoring. We're completing the square. So what number goes here? I would take half of 2, and then I would take that number in. Square it. So what number goes here? 1. Plus 1. What did I really just do? I actually just subtracted 2, yes? So what do I have to do out here? Add 2. Have I referenced Indiana Jones yet? I probably did at least one. Have you ever seen the first Indiana Jones movie? I know it's like from, like a century ago or something. Really just the 80s. Do you remember, has anyone ever seen it? The scene where the boulder comes because he replaces the golden idol with the bag of sand and he didn't do it correctly. That's exactly what the shit we're doing. We're kind of taking stuff away and adding stuff at the same time. So I effectively just added negative 2, so I got to take away a negative 2. If I do that correctly, then the boulder's not going to come and crush me. Yes? All right. So if you divide by 0, you make black holes. If you do this wrong, boulders come at you. I'm very sorry. You got to be careful. How does this here factor now? Who to what? Okay, and then what do you have on the outside? So what's the vertex? Careful. Good, because this would go left 1, up 4, yes? Remember, it's based on transformations. I don't actually have to do transformations, but it's based on it. That's why it's negative 1, positive 4. Does it open up or down? I know I didn't ask for it, but still. Good, opens down because that's negative. What's the y-intercept?
0, 2.
Good, 0, 2. Look at the beginning. This sucks in terms of y-intercept. This is awesome for vertex. Okay. So let's see. We got, what kind of scale can I use? Is any number like crazy? What kind of scale can I use? It's always a consideration. What kind of scale can I use? I can go by what's? Ones. I can go by ones because nobody goes like 7 or 10 or something. Good job, Jeff. Look, I want everybody to look. 1, 2, 3, 4, 6. Okay, just gaze upon that. Enjoy that. All right. I am so tired. I'm sorry. Negative 1. I'm not good with numbers. Let's see. Everybody just accepted what I said. That makes me feel bad. So now the vertex is negative 1, 4. It's okay that I have no room up here because I'm opening down, right? So I feel okay about that. I'm opening down. My y-intercept was 0, 2. So where is there a reflection point? Yeah, negative 2, 2. It's going to be 1 away on the other side. Where's my axis of symmetry? Oh shit. Poor little guy. I'm going to put a little guy holding on for dear life. Okay. Where's the axis? I don't think I've said this, but does anyone know the equation of that dotted line I just drew? Yes, x equals, in this case, negative 1. If I'm only going up and down, I'm not going left and right, what variable is staying the same? Because what variable controls moving left and right? What variable controls moving left and right? X, yes? So if I'm not moving left and right, I'm only going up and down, then x has to be set. X can't be whatever it wants to be. So x equals negative 1. X must be negative 1. What does this equation say about y? Does it say anything about y? That's why y can be whatever the shit it wants to be, because the equation doesn't put any constraints on it. Does that make sense? What would this kind of a line be? Totally. I love you. But this is a x equals. This would be a y equals. I love that. Straight. That's the other one I want. It would be straight. Well, horizontal is really good too. I like it. All right. Oh my God, I'm loopy as hell. Is everybody okay with that? And very quickly, that point we got from just visually, correct? What point is this again?
Negative 2.
Negative 2. 2. What does that mean? What does it mean that it goes through this point? What must work about this point? What must this point do?
Plug in negative 2.
If I plug negative 2 in, I should get a 2 out. So if I plug a negative 2 in, negative 2 times negative 2 squared is 4, minus 4 times negative 2, plus, oh my God, Jeff. Negative 8 plus 8 plus 2. I got a 2 out. So you can always check that last point you get from symmetry. Plug it in, make sure it works. That'll tell you that everything you did is most likely right. It'd be really weird to just randomly get the reflection point right and everything else is wrong. That's not going to happen. I don't know if you guys are with me. It's good to have a way to check your work. Besides graphing and the graphic calculator, because I might put this on a part of the test you're not allowed to use the graphic calculator. So be careful. Don't rely on that sucker too much. What about number 3 here? This is a fantastic word to see. So how's the shortcut work?
Negative B over 2.
Yeah, so what's B in this case?
8.
Yeah, so B is 8 twice, and what's A?
Negative 2.
Yeah, -2. So there's negative mistakes that are easy to make. Negative 8 divided by negative 4 is? 2. And then how do I find the y piece?
Plug it in.
No way. So if I plug in 2, I get negative 2 times 4 is negative 8, plus 16 minus 7 is 1. So what's the vertex? 2, 1. Now, here's the ultimate question. Is it a max or a min? Why is it a max? Because it opens down, so it's the top of the mountain, not the bottom of the valley. Yes? So if it opens down, the vertex is a max. If it opens up, the vertex is a min. So this kind of thing would be maybe a graph of profit, and then I have my goal. My goal is to be there to make all the money. Yes? You guys with me? Okay. How did we do? Anybody try out number 4?
Yep.
Did you get an answer?
Yes.
What'd you get?
25.
25, yeah. So how the shit do I get it? What is the area of a rectangle? So if I had a rectangle that was 5 by 4, what would its area be? 20, just 5 times 4, right? So what is our rectangle?
X times
It's x by 10 minus x. So what is the area of this rectangle? Don't overthink it. 5 times 4 is 20. How do we get this guy's area?
negative
X times 10 minus x. Yes, I'm going to write that. So one thing that you have to get used to as you do a lot of algebra is that variables are just numbers. So whatever the numbers would do, the variables do exactly the same thing. So if I multiply these numbers, I multiply these numbers. These just happen to be numbers I don't know yet. And if I distribute, I get this. Does anyone see why this is kind of wrong, the way that's written? Does anyone get the tiniest bit of, well, shit, why is that like that? Can somebody tell me why this is sort of written wrong?
It's in the wrong order.
Wrong order, kick ass. Because it's really easy to pick the wrong thing for B and A. I'm kind of giving it away what we're going to do. Does this parabola open up or down? Down. Therefore, what is the maximum, another name for? Vertex. So if it opens down, the maximum is another name for the vertex. Do we have a shortcut to find the vertex? Shit, yeah. So all I said was find the maximum, yes? So screw complete and square. I'm just going to do the shortcut. I didn't say write it in vertex form. So how does the shortcut work? What's B? Yeah, 10, and what's A? So what's 10 divided by 2? That's crazy. And so what's the area? 10 times 5 minus 25, 20. Does anyone know what shape that would be then? If x is 5, what's 10 minus x?
square.
It's a square. So anytime you have a four-sided figure and you want to maximize the area, you would make it a square. Can you guys help me out? So 5 by 5, area is 25. What if this side is 6? How long is this side then in this problem? You can do it. This side is x, this is 10 minus x. If this is 6, this has to be 4. What's the area? What's the area? What's the area? What is it, sorry? 24, right? You multiply, yes? What if this side is 7? This side would be 3. What would the area be? 21. Do you see how that's the biggest number so far? So in general, how do I maximize a quadrilateral's area? I make it a square. It's very interesting. When you get to calculus, that's actually going to become a semi-big thing in one of the sections. You'll see. Maybe that'll come back to you when you're there. You're like, oh yeah, Jeff said something about that weird guy I had last semester. Okay. You guys good? Okay. So let me show you one example of a rather disgusting, looking problem that's now much easier. Dadgummit, Jeff. They're here. What if my profit function for a company was this? How excited are you about that equation? Sorry. I looked up and somebody's looking like this. Do you want to, I want to know I'm the CEO of this company, and one of my positions I have filled is a financial analyst, and his job is to track what would make the profit maximum. And normally that's like setting the price of our product. There's more variables, but let's just keep it that. So X here would be, let me say we have a toaster company, yeah? We're the next big thing in toasters. So X is the number of toasters made and sold. And P is the profit. Yes, you guys with me? Collect socks, something else, profit. I want to know the maximum profit and how many toasters I have to make and sell to make that maximum profit. Are you guys with me? Isn't that something that a business probably wants to know? So, an actual equation for a real life business will be more complicated because in real life there's more variables. This is a bit simplified, but to be really honest, it's not going to be that far off from what you would do. So let me ask the question again. I want to know the maximum profit. Can anybody tell me first, why is there a maximum profit? Because it opens down. So there's going to be a maximum, yes? Secondly, where is that max going to happen? At the vertex. So when I say find the max profit, what am I really saying? I'm saying find the vertex. Now I could complete the square. You want to. Look at that first number. Is anybody excited about that first number? So if I just said find the max profit, I'm going to do the damn shortcut. Because all I need to do is find the vertex, yes? And what's the quickest way to find the vertex? If that's all I need. Yeah, so what's B? 80. What's A? Negative. That'll come out to be, what is it, 8,000 divided, so 2,000? I think it's 2,000. You guys do it in your calculator. Be very careful when you put it in your calculator. I think it's 2,000. Yes. So what does that mean? What does that mean so far? What did X represent? What did X represent?
Number of toasters made.
Number of toasters made and sold. So what do we know so far?
That's how many toasters.
In order to make the most profit, I got to make and sell 2,000 toasters. Yes. And depending on the size of our company, that could be doable or not. I mean, these artisan, handmade toasters, I don't think we're going to do it. Right? Carve our toasters out of wood. We're not the smartest. How do I find the profit that goes along with this? The maximum profit. Plug it in. Just shove it in there. Put it in your old calculator. Yeah? What's it gonna be, math boy? Give me a second. 40, 80,000, 96,000. I think it's 95,950. But I could be very wrong. I'm okay if I'm wrong. So can somebody put that in a calculator? Negative 0.02 times 2,000 squared plus 80 times 2,000 minus 50. I already forgot what I said, so it's okay.
79,000.
Damn it. What is it again?
50.
79?
79,950.
Yeah, I was off on the 2 now. All right, I'll be fine. It's late. I'm tired. Who cares? So I could make $79,950 in profit if I get to 2,000 toasters mowed. Sure, Jeff. Made and sold. Say again? What? And don't forget. Profit has other variables, but yeah, you could pretty much see how much we're trying to charge for our toasters. Might not be the most feasible amount of money to charge for our hand carved out of wood toasters. I don't think they're going to last long. So that's the immediate usefulness of the shortcut. Is my God, I don't want to do complete the square. I don't need to. Maybe, potentially. Okay, so I want to do one thing here. Let me see if I can find where I put that. Well, that's right, there it is. I just want to run through a few things real quick. So these are the main ways we talked about to solve quadratic equations, yes? The first level is just factoring. So like, can somebody help me do this? This was from section 2.5, by the way. Can somebody help me solve this equation? Why is it good that it's equal to 0? You guys remember? Why can't I solve this like I normally would? Why can't I just get x by itself? Can I combine all my x terms?
No.
Why not?
There's got
They're not. Why can't you? They're not.
together.
They're not like terms. Yes? You guys with me? So I can't, and one of my x's has a higher power than 1. Right? They have different powers on them. You with me? So then what do? I try to get it equal to 0. It is. And then what do I do with this? Factor it, kick ass. How do you factor this?
Take an X out.
So now I have a number times a number is 0. What must be true? If two numbers multiply by 0, what must be true?
X goes
Yeah, either the first number is 0 or the second number is 0. Careful, I see what you did. You got ahead of me. What's involved in this product? Two numbers. What are the numbers? X and x minus 6. If you tell me what x is, they're numbers. So one number is x, one number is x minus 6. If they multiply by 0, either that first due to 0 or the second due to 0. Now, I love what somebody said, because you should be able to see ahead of time this is going to be 6. So you get 0 or 6. Kick ass. And if you look at the graph, why does that match up? Why does that make sense? 0 or 6. What about the graph tells me I did good? There's X. Yes. That's what makes the output 0. Okay, I love it. Now the next level of this business is here. Let's do this one. How would you solve this? Now real quick, are there different x's with different powers? No, there's one term with an x in it, yes? So I don't have to FOIL that shit out, subtract 8. If you did, you'd get the right answer eventually if you did, but you don't have to. What can I do immediately?
Square root.
Square root. If we square root, what do we have to put?
Plus or minus.
Plus or minus? These kill each other? Can you reduce square root of 8?
2 and 4.
Yeah, square root of 4 times square root of 2. Square root of 4 is 2. Square root of 2 is I don't know. And then I can add 3. And I get something that looks very much like what I would get from quadratic formula. Because what we just did is an alternate way to do quadratic formula. If I multiply that out, subtracted the 8, I would do quadratic formula. I would get that answer. It would just take longer. Yes? Okay. So we got factoring. We got the square root method like we just did. We got completed square, which we've done enough of. And then we've got quadratic formula, which we've done probably enough of. So let me ask you this real quick. This will be the last thing we do, and then I'm going to let us out nice and early. Can somebody, I like this problem, can somebody help me? Can we see the vertex?
Yes.
Does anyone see something that feels like it's missing? Does anything feel like it's missing? Do it again. Like the, okay. There's no number out here, correct? So if there's ever something that's not here, I can just put plus 0 if I want to. You don't have to. But now, what's the vertex? Is it in the right form? A x minus h squared plus k, right? So what's the vertex? Negative 1, 0. Kick ass. Is it a max or a min? Min. Why is it min? Opens up, so it's the bottom of a valley, not the top of a mountain. What would the 1/2 do as a transformation?
Make it.
It would smush it, like somebody sat on my head. Yes? Okay. So we got the vertex. What's the y-intercept? Yeah, this time I just got to plug a 0 in. I don't have the original form of it, yes? So if I plug a 0 in, 0 plus 1 is 1 squared is 1 times 1/2 is? 0 plus 1 is 1 squared times 1/2 is? 1/2. Okay. Too bad. So I got 0, 1/2. I got negative 1, 0. Where is there another point? That's true. So there's got to be another point there. What's the equation of the line of symmetry?
X equals
Yes, so the line of symmetry is always x equals the x piece of the vertex, if it's opening up or down. Oh yeah, domain and range. What's the domain for any up and down parabola? Because it goes forever. It's all real numbers, yes. What's the range for this parabola?
greater than.
Yeah, the lowest output is 0 and it goes up from there. What if I shifted it down? Would that change the range?
Yeah.
Yes. What if I shifted it left and right? Would that change the domain?
No.
No, because the domain is all real numbers already. So if I just shift it, it don't do nothing. Okay. I love it. Yes.
On the practice test,
Yes.
number 8, it talks about like finding a line that's perpendicular to another line. I don't remember if you talked about that.
Oh yeah. Very quickly. Thank you, Christine. I need somebody to keep me straight. Do you guys remember if I have two lines that are parallel, what makes sense? Even if you forgot, what makes sense about their slopes? What do their slopes have to be related? They have to be exactly the same, yes? If one is just a little different, it would eventually overtake the other one. They would cross, it wouldn't be parallel. So if I have two lines that are parallel, they're exactly the same slope. What about two? What does perpendicular mean? Not just not parallel, because that could be any. Perpendicular specifically means they have to meet at a what kind of angle?
90 degree.
90-degree angle, yes. So what's one thing that makes sense? If this slope is what's from your perspective positive, yes? The other one's got to be negative. But that's not all. If one slope is 3, the other one's got to be negative 1/3. So this is beautiful. If two lines are parallel, exactly the same slope. If two lines are perpendicular, completely opposite. So how many ways is there to be opposite? What's the opposite of 2? Well, either -2 or 1/2. So in this case, you do both. So if one slope was, let's say one line slope in the perpendicular, if one line slope is, let's just do slope, is -4/3. What is the slope of the other line? Completely make it opposite. Change the sign and flip it. What do you get? 3/4. So if you know one line slope, what is the perpendicular line slope? Completely opposite. Change the sign and flip it. Kick ass. Alright. So on Tuesday, I'll have the answer key for the practice test, and we won't do any new stuff. It'll just be completely dependent on your questions. So come with a lot of questions ready on Tuesday. And we'll have a test on Wednesday. Finally. When is the quiz corrections due? Nope. Good try. Quiz corrections. Day of the test. Everything is due the day of the test, except homework corrections will do the day of the final. You do them when you can. Alright guys. We'll see you next week. I'm gonna sleep all of Sunday, I think. Sounds good to me. Oh yeah. Thanks, man.